What's up, guys? Welcome back to the channel. And today we are going to continue on episode two of the part two of the series, designing an inverter from scratch. So, this is our circuit. So, in the previous video, I have discussed how this circuit works and um, the feedback system and everything. If you haven't watched that video yet, go ahead and watch the video from the playlist. And so in this video, we are going to talk about the transformer uh, wiring and issues I had with the circuit. So let's get started. So this is the transformer, guys. So it has three wires. So this is a UPS transformer, but this is not the original form of it. Um, it originally looks like this. So you would need to upgrade the transformer a bit, and you have to cut uh, this paper right here in the middle, and there will be two wires connect together, and these wires are coming out of it, and you have to separate the each pairs and connect them together to form uh, this. So um, it it's a easy task. So I did it right here. I'll put a video in the description where you can find someone doing it, so you can easy to copy him. So, and after doing that, I made this circuit according to this diagram. So this diagram I took from the other YouTube channel. So um, so I tried it, and my microcontroller got fried. So it literally smoked right here, and I destroyed one MOSFET, and the other one is fine. But I destroyed one and the microcontroller. Maybe I have to heat up this microcontroller and replace it with a new one. So I would have to do it, or use I have an Arduino Uno laying around. Maybe I can use it next time. So in this circuit, um, I was thinking of adding a diode right here. So this is a SPWM signal, So SPWM signal is like this. It changes the on time dependent on the sine wave. So these are all ones and zeros, and diodes can switch on and off. So it's easy to use a diode. And so in the next circuit, I'm going to add the diodes, and also um, I should add a diode between this 12 volt and the drain pins to prevent uh, the back EMF from destroying the MOSFET. Um, so I have to add a Zener diode, a 20 volts max between drain and this 12 volt pin. So the regulator is fine, and the resistors are fine. The problem is the MOSFET. Let me run the real quick. So I have 12 volts right here, and I am supplying it. Uh, I can supply to the regulator. Everything turns on at first, but you see that all three LEDs are lit up, and um, it is not generating any signal, and it's heating. It's heating. Like if I put a water droplet, you can see it bubbling. So I mean, the water is boiling right now. You see the microcontroller is gone. So, so we would have to replace it or fix it. And one of the MOSFETs are also gone. You can test MOSFETs with a multimeter. Let me add it to continuity. Let's see. So this heatsink mount, this one is connected to the drain, and I'm going to probe it. So no short circuits. The drain, source and gate. Yeah, it's shorted. So this one's fine, and this one's gone. So its source pin is connected to the gate. I think uh, it might have gone through. So let's look at this bracket. So this source pin is connected to grid directly, which goes to the emitter through the 1K resistor, and it goes to the regulator. So and let's have a look. Uh, this is negative and this is fine, but it can't go through here. Yeah, it goes through this 1K resistor, but I don't know how it damaged the Arduino. It's it's hard to find the error in this. So it could be the back EMF which is going through the power supply to the Arduino, and it could be the reason uh, because the ground pin is directly connected to the power supply. There are no that, uh, so it could be the reason. Do you guys have any suggestions? If you have any suggestion, comment that down below, and we would have to rebuild this with the modifications, and I'll get back to you soon. Until then, bye bye.